All right, so for number 14, it says prove that the two equations are equivalent by simplifying the equation on the right side of the equal sign. You do not need to justify your steps. Good to yeah. So good question. We'll have to talk about that. Maybe you can just get like a couple points a day for being on task or something. Okay. Riley, what would you do first on this whole nonsense right here? Okay, so we're not solving the equation. That is confusing because it does equal something, but all they want us to do is just simplify that side. So you can just ignore the left. So what would you do with this first? Okay, so 5, what? No, 5x minus 10x is, hold on just a second, we'll talk about that in a second, is what? Negative 5x. Okay, so that gives me negative 5x minus 7 plus 2 times 3x plus 1. You're right, there is a 3x here, but I can't do anything with that yet because it's locked up inside these parentheses. Okay, so we're going to have to deal with that in order to deal with that. Okay, so Talia, how could you get rid of those parentheses? Okay, so 2 times 3 is 6x. 2 times 1 is 2. Awesome. Okay. Does that make sense, Nathan, that we had to do that first? Yeah. All right. Weston. Okay, Nathan, take it home then. Simplify that. Okay. Oh, so remember, like I was telling Riley, we're not solving this equation, we're just simplifying this side. So how can I simplify this? Okay, so negative 5x is plus 6x is 1x, or just x, and then negative 7 plus 2 is, what's negative 7 plus 2? Nope, this is negative, that's positive, so it's negative 5, okay? So they're the same, yeah. And I think they're going to be the same each time. I don't think they're ever throwing us a curveball and having it not work out, but I guess we'll see. Okay, Luis, what would you do to simplify the right side of this? Right, because of the parentheses, yeah. Okay, so you want to combine the numbers? Okay, so the 62 is positive. So 24 and 62 make 86 minus 10 times 2x plus 8 plus 7x. Okay, so in the same way that Riley started out number 14 by combining the x's, Luis is going to start out number 15 by combining the numbers. Okay, then after that, Matthew, what do you want to do from there? Okay, so that, yep. Okay, so hang on just a sec. So then Matthew distributed to get rid of the parentheses, just like Talia did in the other one. You want to keep going? Okay. Subtract, because this one's negative. So 86 minus 80 is, no, 86 minus 80 is 6. And then negative 20x and 7x makes negative 13x. And that's the same as that. So that one checks out too. All right. Okay, how about number 16? This looks pretty much the same as the other ones. Dylan? Nope. This just kind of came at us out of nowhere. Yeah, yeah. But this one, you got 2x right here and you got negative 13 right there. Those are not like terms, so you can't combine them. So we're going to have to go straight to getting rid of the parentheses. Okay? So I'm going to distribute this negative 3. So what's negative 3 times negative 4x? Right, 2 negatives make a positive, so that's 12x. What's negative 3 times negative 5? Awesome. And then the negative 13 just chills. All right, no Duran. Okay, Talia, what can you combine in there? Okay, 2x and 12x makes a total of 14x. And then 15 take away 13 is 2. All right, and that is the same as the stuff on the left. So, yeah, that checks out. Nathan, how about number 17?
Would you combine the parentheses? Could you?
Because they're the same, you could, yeah. So you have essentially 6x plus 3s minus 5x plus 3s. So how many x plus 3s do you have? No. No. If you have 6 of something and you subtract 5 of that same thing, how many of those? 1. Which is just x plus 3. Okay? So, Matthew, Nathan did this. You want to make sure you... Okay. Nathan did this. Okay, Nathan did this in like a really different way. What I would have said is distribute the 6, which would give you 6x plus 18. And then I would have distributed the negative 5, which would give you negative 5x minus 15. And then when you combine those like terms, you get x plus 3. But Nathan, thinking outside the box, noticed that the x plus 3s are the same. So anytime you have 6 of something minus 5 of the same thing, then you're just left with one of those things. Like if you have 6x minus 5x, you have 1x. If you have 6 chickens minus 5 chickens, you have 1 chicken. If you have 6x plus 3s minus 5x plus 3s, you have 1 x plus 3. So that's a faster way to get to the end there. That was clever. Nicely done. All right. So again, those two things match up like we would expect them to. Okay, this looks exciting. Okay, whoops, nope, he's going too. All right, Riley, back to you. So can we get rid of some parentheses? Okay. And since you're on a little roll there, let's distribute the negative 3 to those also. Okay, negative 9x minus 3. Good. So first thing to do there is get rid of the parentheses. Remember, order of operations. Please excuse my dear Aunt Sally. Parentheses comes first. Hang on just a sec, Lindsay. Dylan? What would you do now? You what? You want to do the x's? Okay. This time there's 3 terms in there with x's. so I have to go 14x minus 5x minus 9x. How many x's will I have left after all of that? 0, yeah, because 14 minus 5 is 9, and then 9 minus 9 is 0. So those actually all cancel each other out. So then you're just left with 7 minus 3, which is 4, which is what you're trying to get to there, okay? Lindsay, did you figure that out? Okay, hang on just a second. Okay, Luis, what do you want to do with this? Okay, what do you get when you do that? Okay, what do you do from there? Okay, so that gave you 5x. Okay, 12 minus 12 cancels. So 5x's minus 4x's is 1x. Okay, which is what they wanted us to get. Okay, and then number 20, anybody want to give this one a try? Write an expression that equals x minus 13.
I'll do it.
Okay, you got it? What you got? What's that? But it says it must have at least 2 sets of parentheses and 1 minus sign. So I have 2 parentheses and a minus sign in there. 20, let's go 20x. Okay, so I want to end up with an x. So that means this stuff is going to have to be 19x, right? To make it work out. Well, nothing times anything is 19, so let's flip this around. Let's make this a 20, what'd you say? 25x? Okay, so what 2 numbers can I multiply together to get 24? 8 and 3. If I make that an 8 and make that a 3x, so this is 25x, that's minus 24x, that'll give us an x, right? Okay, throw a number in here. 7, plus or minus? Minus, right? So if this is a minus 7, then when I distribute that, that would make a positive 56. What does this have to be so that when I combine it with a positive 56, I get a negative 13? 43, yeah. No, let's see, this is going to be plus 56. Okay, let's switch this around, hold on. Let's make this be positive 7. So this is negative 56, and then it would be positive 43. Okay. Okay, so 25x minus 24x, that would give us x, and then 43 minus 56 gives us negative 13. Okay? All right, I'll take it. Yeah, well, I mean, he said of the year, so I just went with it. Okay, so this is like a summary of all the stuff that's been in the lesson so far. And so I imagine what we'll do is we'll have a test on the whole thing. You hate to do that Monday, especially when kids are gone. Okay. No, then that would be terrible for you guys because then.
Everybody's going on vacation.
No, I know, but if we wait till after winter break, I mean, come on, you would forget all of it. There's no way. Yeah, to have a test over this whole thingy. Yeah. You're not going to study. How about do it? Okay, Monday or Tuesday? I don't know. We'll see.
Tuesday and we study Monday.
Okay, Tuesday and we do more review on Monday. All right, that makes sense. All right, so yeah, so test on this Tuesday on this, yeah, whatever this is called, module. All right, so it says in our work so far we have worked with linear and exponential equations in many forms some of the forms of equations and their names are, you got slope-intercept form, our old friend y equals mx plus b. You've got point slope form. We spent a lot of time working on that yesterday. The recursion formulas are not something that we spent a bunch of time with, okay? But an example of this would be this one right here. This means that you're starting with 1, and then to get the next one you add a half. So the next one would be 1.5, and then 2, and then 2.5, and so forth, okay? Then we also did the exponential functions, which is where you're multiplying.
I didn't get that.
Uh-huh. So this right here where it says f of 0 equals 1, this is your starting number. And then this is what you do after that. So in this case you would start at 1 and then, what's that? Yeah, exactly like a table. So your starting number is yep, absolutely. So your starting number is 1, and then it says add 1/2, so the next one would be 1.5, and then 2, and then 2.5, and then yeah, it's a pattern. You're just adding a half each time. Okay? Okay. You have, okay. All right, Dylan? There are, yes, there's about 8 or 9 birds there, a couple more coming in. Yeah, they're all over there eating birds. Yeah, there's like 10 birds. Yeah, just stand up, take a look. They're all happily eating. Oh, okay, everybody's going to look at the... okay, so Nathan, did that make sense? And Talia, you got that in the table, it makes a pattern. So we also can do exponential functions. Remember, exponential functions are when you are multiplying. So in this one, you'd be starting at 10 and then multiplying by 3 each time. This is the same way to write that, just in a different form. You're starting at 10. That's what this means. So when x is 0, y is 10, and then the next one would be 30, and then the next one would be... yeah, exactly, yeah. And then 270. So this is another way of writing this same information. So this is just saying you're going to start at 10 and you're going to multiply by 3. And this is saying you're going to start at 10 and you're going to multiply by 3. Okay? Just written in a different form. Yeah. Yeah. All right, Lindsay and Alexa, can you guys? Yeah. Okay, so what we're going to do now is we're going to take a look at, I think, like 10 different situations, and we're going to see which one it fits. And we're also going to write an equation, and we're also going to talk about whether it's discrete or continuous. Okay? So here we go. First one. In his job selling vacuums, Joe makes $500 each month plus $20 for each vacuum he sells. Write the equation that describes Joe's monthly income, I, as a function of the number of vacuums that he sells. Do it on your own. Do it on your own. Write it down. Don't say it out loud. Write it down. Don't say it out loud. Yes, write the equation down. Don't say it out loud. Okay. Yeah, you're good. Okay, then tell me whether it's linear, exponential, neither, continuous, discrete, or neither. Okay? Let me circle that on your paper. Don't tell me. Don't say it out. Okay. Okay, so that's why we're having this little chit-chat right here to remind you of those things. So first of all, let's get the equation. Luis, what did you come up with for the equation? How much does he get for each vacuum? 20. So it'd be 20n. Okay? So his income is that he starts out with guaranteed $500 for the month, and then he gets $20 for each vacuum that he sells after that. Okay? So I equals 500 plus 20 times n. Okay? All right, so the next question is that discrete or continuous? So Talia, remember what we're looking for when we're deciding whether it's discrete or continuous is whether we can deal with decimal numbers or not. So Dylan, would you be able to have like decimal vacuums? No. So you are only selling an entire vacuum or you're not. So that means that this is discrete. Okay? Then, Dylan, the fact that it's going up by the same amount each time means that it is linear, exponential, or neither. Linear, yeah. Linear means that you're adding or subtracting the same amount each time. Exponential is if you're multiplying, yeah. What if what? No, what would be exponential would be a really sweet job. Exponential would be, okay, we're going to multiply your income by the number of vacuums that you sell. Yeah, that'd be really awesome. Yeah, but no, since you're right that it's going to change, and that's why we're using a variable right here, because we don't know what that's going to be, but we do know that you're always going to add $20 onto income for every vacuum that you sell. Okay? Yeah, they wouldn't be able to afford that. Yeah. Okay, next one. Write the equation of the line with a slope of -1 through the point -2, 5. So this is what we spent a long time on yesterday. See if you can come up with that equation on your own. Those are good ways. Life is good. Maintain it for as long as you can. Okay, so let's see. Riley, did you come up with an equation? No. Okay. So, since they've given us a point and the slope, it seems like it makes sense to use the thing that we were doing yesterday. Okay? And if you don't remember that, what that is it's y equals the slope, parentheses, times x, opposite of x, so since x is -2, this is going to be +2, and then add 5. Okay? So the form of the equation that we used was point slope form, and that's because they gave us a point, and they gave us the slope. Okay? So when you have those two pieces of information, then point slope form is a pretty good way to go. Okay? All right, Talia, linear, exponential, or neither? I feel like it's linear too because it said write the equation of the line, and line means linear. Okay? Talia, continuous, discrete, or neither? I think it's continuous too. Good for you, because you can put whatever number you want in for x. It doesn't have to just be whole numbers. Okay? So that means that it is continuous. All right? Okay, number 3, write the equation of the geometric sequence with a constant ratio of 5. Constant ratio means, this means multiply by 5, okay? And the first term is -3, so give that a chance. Nathan, were you able to come up with a...
I didn't really understand this one.
Okay, but it's a geometric sequence, so that means we're multiplying by the same thing each time, so we can't use point slope for that. What do we, no, y equals -3 times 5 to the x. Okay?
That's the one on the test, the slope?
Yes, exactly. That are like curved or whatever. Uh-huh, good. Yeah. Okay. So let's see. Would that be what, Matthew? Linear, exponential, or that would be exponential because you're multiplying. Okay. And it would be continuous because you can put in whatever number you want for x. Doesn't have to just be whole numbers. Okay? All right? All right, let's take a look at the next one. Write the equation of the function graph below. Now, some of you struggled with this a little bit on the quiz we had the other day. Remember that you can always take a graph and turn it into a table by finding some good, clean points on the graph. Okay? So if that's what you need to do to be able to come up with the equation, then that's what you should do. Okay? So again, let me give you a quick second. If you can do it just by looking at the line, then that's great. Okay, Luis, did you come up with a formula? Okay, what'd you do? Okay, so Luis went with the slope-intercept formula because the slope is 3/4 because of what Matthew said, up 3/4. And then you can just look at the graph and see that the y-intercept is -3. Can anybody write this using the point slope form instead? Parentheses x. Okay, let's pick a point that we're going to use. Oh, you want to use that? So what's the coordinates of the y-intercept? Either one, doesn't matter. It'd be what? 0 minus 3. Okay, so y equals 3/4 x minus 0 plus 0 doesn't matter. It's the same. And then minus 3. Yeah. And that would be the same thing in point slope form. So either one of those will do. Okay. All right. That's if you're trying to find the slope if they just give you the 2 points, not the graph. So if you can't just look at the graph. Yeah. Okay, Matthew, linear, exponential, or neither? Definitely linear because it makes a straight line. Okay. And it's also continuous. It's not like independent points. It's one continuous line. All right. Okay. I think that we should do 2 more. That'll get us halfway through these, and then we can finish the other half on Monday. Okay? All right, so next one says the population of the resort town of good old Java Hot Springs in 2003, you go girl, is estimated to be 35,000 people with an annual rate of increase of about 2.4%. Write the equation that models the number of people in Java Hot Springs with T equaling the number of years starting in 2003. Okay, go.
35,000.
Yep, 35,000.
And then times 2.4.
1.024 to the T. Ask Luis. I just wrote down what he said. Okay, so anytime you have a percent, you're really never going to write the actual percent in the equation. You're always going to change it into a decimal first. So that's where Luis got the 0.024, and then the 1 is because of the 35,000, the population that you had to start with. Okay. Okay, linear, exponential, or neither. It would definitely be exponential. Anytime you're working with percents, it's pretty much exponential. Yeah, it gets discrete because it's population and you can't have half people or whatever. Okay. What's that? Half of a person? No, you cannot have half of a person. There's still a person. Oh my Lord. All right, last one for today. Jessica's science fair project involved growing some seeds, I bet it did, to see what fertilizer made the seeds grow fastest. One idea she had was to use an energy drink to fertilize the plant. Good idea. She thought that if they make people perky, they might have the same effect on plants. This is the data that shows the growth of the seed each week of the project. So, as before, start by writing an equation that models the growth of the plant over time. Go. So you got it, Nathan. We got to figure out what the starting number is. What was it? How much is it going up by each time? 1.2. So that means it went down by 1.2. So that means she didn't plant a seed. She planted a seedling. Thanks for lying to us about your science project, Jessica. F minus. Okay. Anybody have the equation that goes with that then? Y equals. That's as far as you've got. 0.5, because that's how tall it was to start, plus what? 1.2x, because it goes up by 1.2 each time. Okay? That would be linear, because it's going up by the same amount each time. It would be continuous, yeah, because the time she's measuring it every week, but you could measure it in between weeks if you wanted to. Yeah, it's growing continuously. It doesn't just like jump from one thing to another, so it would be continuous, okay? All right, so we will finish that up on Monday then.